Today we're going to be talking about solving compound inequalities. We're still in section 1.5 and going to be finishing up this section today. So first of all, compound. That means we have multiple inequalities. Usually we're going to be talking about two different inequalities working together. So there's two types of compound inequalities. The first one we're going to look at is the and inequality. Now what does and mean? And right, means it has to be true for both situations. For both situations. For instance, people I'm going to select are males and wearing blue jeans. So the people I would be selecting, they have to be a male and they have to be wearing blue jeans. So like right now, I know you can't see, but I'm wearing kind of like jogging pants and I'm a male. I pick one of the criteria but not the other. So I would not be a possible selection. It has to be true for both. So when we're looking at these problems, the first one that we're going to look at is 11 less than 3x plus 2 and 4x plus 3 less than or equal to 23. We want to solve both of these problems and then kind of put them together because our answer has to be true with both of them. So we're going to add negative 2 to this one, get 9 less than 3x, divide by 3, and I end up with 3 less than x. If we flip-flop this means x is greater than 3. Now to solve this one, I add negative 3 to both sides, end up with 4x less than or equal to 20, divide by 4, and I end up with x less than or equal to 5. Now we've been working on these for the last couple days. These are kind of straightforward. Hopefully this is getting easier to do. Now, when we're looking to graph these on a number line, I'm going to do the one on the left in red, the one on the right in blue. So, I see I have a 3 here. So it says x greater than 3. Open circle, and it means I will be shading to the right. Everything is greater than 3. With the blue equation over here, there's 5. I know 5 is bigger than 3. It says less than or equal to 5. And it's going to go this way. Now, where is it true for both graphs? It's in the middle. So, our final answer when we graph this, we will put an open circle on 3, a closed circle on 5, and it's where they intersect. It is this area in here where it hits both of them. Okay. So it's between them. It's true for both. And we're going to see a pattern with these ands as I do the next problem. So if you need to stop to rewrite and check to see what I did, please stop the video and review it. Number 2. Now if you look on your notes, number 2 is written a little bit different. And a lot of times the and problems are written this way. We have 17 less than 4x minus 5, which is less than 55. So you're like, how do I get 2 problems out of that? We're going to rewrite this. We're going to count this as 17 less than 4x minus 5, and we're going to repeat this 4x minus 5 is less than 55. Just like we were before. Typically with us mathematicians, we write it this way to save some time. Go ahead and solve it. Add 5. Divide by 4. And we get 5.5 is less than x. Or x is greater than 5.5. Over here, we add 5. 4x less than 60. Divide by 4. And we have x less than 15. So, looking at this graph, and look at which number is smaller, the 5.5, and I have the 15 over here. Now this is greater than, so it's going to be an open circle. We would be shading to the right. With less than 15, open circle, shade to the left. And you'll see where they overlap. So my final answer will be what's in the middle. All these answers, all numbers between 5.5 and 15. So at the bottom of the notes it says to sum up. When we're doing and problems, unless it's a special case, which we may talk about later, we will always graph what's in the middle. There will always be this in the middle that's being shaded. Every time for an and problem. They will be this way. Right? So, where it says sum up, make sure you put in there shade in the middle. Shade where they overlap. Now, we're going to talk about or situations. So the or problem, and what do we mean by or? We mean it can be this or that to be a solution. For instance, for team people I want to choose on my team, they're going to be wearing a red shirt or they're going to be wearing a blue shirt. They don't have to be true for both, just for one. So that's what our graph is going to look like as well. So it could be either rule, and it'll be a solution. These will always be listed as ors. 6x minus 7 greater than or equal to 17, or 5 minus 3x greater than or equal to 26. So we solve these the same way. Add 7. 6x greater than or equal to 24. Divide by 6. And we have x greater than or equal to 4. Over here, adding negative 5. We're left with negative 3x greater than or equal to 21. We're going to divide by a negative 3. When we divide by the negative 3, we have to flip the direction of the inequality, and we get negative 7. Now you're going to see that this graph's going to look a little different. I know negative 7 comes before 4. It says x greater than or equal to 4. Close circle, and I shade to the right. For this one, x less than or equal to negative 7. Close circle, and I shade to the left. So this means all numbers to the left of negative 7 are true. All numbers, including 4 to the right, are true. So again, we're not shading in the middle anymore. Number 4. (5x plus 2 greater than 32) or 3x minus 8 less than 22. Solve our two problems. Add negative 2. End up with 5x greater than 30. Divide by 5. And we have x greater than 6. This one, we add 8. 3x less than 30. Divide by 3. And I get x less than 10. So, when we graph this one, I see 6 is over here, and then we have a 10. So, x greater than 6 is going this way. X less than 10 is going this way. Now, this is one of those special cases. What happens with all of this? My whole graph is included. Every single number will be true in this example. When this happens, this is all real numbers for our solution. So this looks a little bit different than the first one. But again, in my example of red shirts and blue shirts, maybe they have a red shirt on here and there's a blue shirt on underneath. It just overlaps. That's okay. But here we want to include everything. So this is